The question was, can you talk more on the 2/3 pitch of the alternator? Do all generators have the same pitch? And what are the other pitches? How do they affect the operation of generators?
Okay. So what I'm talking about here is I'm talking about when you have the barrel of an alternator. So I'm looking down the alternator, right? And we're running the windings, wrapping the different windings. If I were to do it if I did it at 12 o'clock and then I came back at 2 o'clock, a full pitch would be 90 degrees if I went 12 o'clock and 3 o'clock. The industry in general does 2/3 pitch. So I'd be 12 o'clock and 2 o'clock. And what that does is that creates a certain shape sine wave, which reduces the impact. Actually, it eliminates the impact of third order harmonics that are produced by the load and their impact back on generators. If you think from harmonics, I've got different order, 3rd, 5th, 7th, 9th, 11th, different order harmonics. Because of the shape of the sine wave and the 2/3 pitch, the industry, and I'm telling you this, everybody has gone to a 2/3 pitch alternator, right? Us, CAT, Cummins, MTU, Relco, whoever. Everyone has a 2/3 pitch alternator. It creates a certain shape sine wave. And to our naked eye, we wouldn't even notice the difference. If you had a non-2/3 pitch alternator, the shape of the sine wave would be different. The zero crossings would happen at the same time. The peak would be the same, but how we get there, one sine wave would be maybe a little fatter than another. And the problem would be if I have two pieces of equipment, one's 2/3 pitch and let's say one's 6/7 pitch. Those sine waves are going to be different shapes. So at the zero crossing, I'm cool. At the peaks, I'm cool. The problem is getting there, my sine waves are going to be different. And that means with different voltages, I've got now circulating current. I've got maybe as I'm on the way up, I'm sitting here at 235 volts, and I'm on the way up over here, and I'm only at 230 volts. So I'm 5 volts higher. Well, that's a difference in potential between two pieces of equipment that are on the same circuit. And once you have a difference in potential, that causes current to flow. So you would have what's called circulating current. And that's a big challenge to deal with. We don't want that's wasted energy within the system. All the energy, all the current needs to be flowing towards the load. What I'm getting at here is, I can tell you, Cummins, Generac, Relco, all use 2/3 pitch alternators all the way across the board. Caterpillar, back in the 90s and into maybe 5 years ago, came up with something called an optimum pitch, which what meant they were going to do 2/3 pitch if it was cost effective. And if it wasn't cost effective, they were going to do a different pitch. Because back in the 90s, frankly, we're talking maybe a 600 kW generator. You didn't parallel 600 kW generators. It just didn't happen very often. Right? That was, again, that paralleling switchgear issue, the cost and all that. So if a 600 kW generator was 6/7 pitch, nobody really cared. It was mostly sold as a single unit. So for a number of years, in a cost-effective method, they used different alternators at different size units. Some were 2/3 pitch and some weren't. Okay. And again, I know this having been a 20-year guy with what they were doing. And I've had projects where we had different pitch alternators. You had an existing unit, you got a new one, and they were different pitch, and it was very, very difficult to make that happen. You had to do something like a neutral pitch limiter or something along those lines to help reduce the amount of circulating current going through there. But just a very difficult thing to address was a 2/3 pitch. In one particular project, we took the non-2/3 pitch alternator off an existing unit and bought a 2/3 pitch alternator just to make the system work easier. Okay, so 2/3 pitch, it's not a huge conversation, and it's only a conversation if it's a Caterpillar product. I'm not trying to bash Cat. I'm just telling you this is what they did. And so what you got to do is you need to get the serial number of the alternator itself and roll up to Cat or whatever and say, hey, I need the data sheet on this alternator to know what the pitch of this alternator is, because it will not be written on the data on the nameplate of the unit, but you need to know, right? Because you're going to bring in a 2/3 pitch piece of equipment that doesn't match with that one, and it's going to make life very difficult.